Hi guys, welcome to our channel, the Tutor. So this is the third video from solution chapter. The first one was about concentration terms and the second one was about solubility of solid in a liquid and gas in a liquid, in which we talked about Henry's law also in detail. If you're thorough in those topics, then it's fine, or else go watch those videos and come here for better understanding. So today in this video we are going to see about Raoult's law, Dalton's law, vapor pressure of solids in a liquid, non-ideal solution and ideal solution. First one is Raoult's law. For a solution of volatile liquids, the partial vapor pressure of each component of the solution is directly proportional to its mole fraction present in the solution. This is the exact definition of NCERT. For definitions you have to stick to NCERT. Raoult's law equation is Pa equals P naught A into XA. Pa is the partial pressure of component A. P naught A is the partial pressure of pure solution A at that particular temperature and pressure. And XA is the mole fraction of component A in the solution. This equation is according to the definition which we saw just before. If you are not clear with this equation yet, after seeing Dalton's law it will be more clear. Next we are going to see about Dalton's law. According to Dalton's law of partial pressure, the total pressure over the solution phase in the container will be the sum of the partial pressures of the component of the solution. Let's take a situation in which we have a closed container. Inside that we have component A and B. Okay, so let's try to understand Raoult's law and Dalton's law from this situation. In that, if we want to calculate the total vapor pressure because of those two components, first we have to use Raoult's law. From that we will be able to calculate the partial pressure of component A and component B according to Raoult's law's equation. That is, Pa equals P naught A into XA and Pb will be equal to P naught B into XB. And by Dalton's law only we will be able to calculate the total vapor pressure, which is equal to partial pressure of A plus partial pressure of B. From Raoult's law we got the final equation as shown. Next one is vapor pressure of solution of solids in liquids. This topic is very conceptual, so try to listen very carefully. In pure solvent, the surface of the solvent is fully covered with the solution which is volatile, which will evaporate very fastly, right? And if you add some solid solute to it, it will not evaporate, but it is present at the surface. So this will block the volatile component to evaporate. As a result of it, the vapor pressure will be decreased. This is a separate topic in this chapter, that is colligative properties. It is given at the end, so we'll see about this topic in detail in the next video. Next we are going to see about ideal and non-ideal solution. First, ideal solution. The solution which obey Raoult's law over the entire range of concentration are known as ideal solution. And non-ideal solution is a solution does not obey Raoult's law over the entire range of concentration. Then it is called non-ideal solution. It is just opposite to the ideal solution. And there are two types of non-ideal solution. The first case is if AABB, that is interaction between themselves, is greater than interaction between the other type, then it is called positive deviation. And the second one is interaction between other type of molecule will be greater than the interaction between its own molecule. That is called negative deviation. So here I'll tell you a trick sort of thing to remember this during your examination. If you are alone and not at all interacting with any of your friends before the examination, you will study properly and you will improve your result. That is like positive deviation. And in the other case, if you are interacting with your friends, playing games or something like that, that will reduce your result. That is like negative deviation. Compare this with the two types of non-ideal solution. So I guess this will make you guys not to forget this concept during the examination. The example for positive deviation is aniline and phenol because they interact with themselves instead of interacting with the other molecule. And a negative deviation example is acetone and chloroform. The main reason for this is hydrogen bonding. The main interaction between them is hydrogen bonding. As you guys can see, carbon is bonded with oxygen, which is the second most electronegative atom in the whole periodic table. So it pulls all the shared pair of electron towards itself. So it will attain partial negative charge. And in chloroform, carbon atom is bonded with 3 chlorine atom, which is the third most electronegative atom in the whole periodic table. So it will pull all the electrons towards itself, which will make carbon to be partially positive, which will be transferred to hydrogen also. So it will also be partially positive, and oxygen was partially negative. So it will form a bond which is called hydrogen bonding. This was the reason why interaction between chloroform and acetone was greater than interaction between themselves. Thank you for watching this video, and don't forget to share this video to your friend who didn't understand this topic properly. Bye.